Alright guys, we're going to look today at transformations of functions. We've talked about a few of these. Vertical translation, slide up or down, f of x plus a number, f of x minus a number. We know in linear, it's plus b, and then exponential plus k. Alright, now horizontal translation, slide left or right. We know that exponential of what we've been talking about here lately, it's f of x equals ab to the x minus h minus fx equals ab x minus h. Come on. And we know that h tells us to go left or right, and we know it's opposite, so if it's negative, so for example, if it's -3, we know we're going to go right 3. If it's x plus 3, we're going to go left 3, because it does the opposite with the negative sign. Alright, and then let's look at shrink. Shrink, flatter slope, where c is between 0 and 1. So what that tells me, for y'all's concern here, let's see here, a flatter slope would be something like this one. 2/3 is a number that's in front of b, and it's called c because they input another part of the function, but we're just going to say the number in front of b, where a is, because it's a times c, so a function would be a times c b to the x minus h plus k. And so they're saying that this number right here, but it's really, if you look at it for our purposes, it's going to be a. If it's between 0 and 1, it's going to be flatter and a stretch, steeper slope, just like this one, because the 3 right here is going to make it steeper. And we can put them in our calculators and see that. So those are different kinds of transformations. For other purposes, if b, so right here, if in our equation, if b here becomes, say for example, if I got 2 to the x, and we know that's going to be graphed, okay, just like this right here. Alright, so there's that function right here, and then say we graph y equals 1/2 to the x, and that's our b value once again. We know we're going to have the same y-intercept here. Alright, it's just everything's going to be flipped the opposite way. So that reflects it over the y-axis here. So everything's just going to flip over. Just like that right there. So if I change that, this is called decay. And this over here is called growth. Because this one's increasing and this one's decreasing. Alright, so different kind of moves there. And we also remember that if A is a negative, we talked about this before, if A is a negative, so this one is going to flip Y axis. So for example, if I made, so here, and if I also did it like this, if I made A a negative, negative A, B to the X, so for example, Y equals negative 2 to the X, so we saw our original here, this one will be 2 to the X here, alright, so that's our original 2 to the X, alright, and then if I use negative 2 to the X, it's going to just flip everything over. Hold up. It's going to be the same graph, have the same it's just going to be flipped over and have different, it's going to have negative y values. So if A is negative A, then our function is going to, so this one, flip over X axis. Alright, now let's look at a couple more examples. So right here, we're going to look at these tomorrow, but you're going to tell me what is the difference from the parent graph here. So we're going to compare it to the parent function of, and we talked about this is our parent function for exponential, f(x) equals 2x. So tell me what each one of these, and make a small sketch of the graph, what it does to our parent function. Does it move it up, down, over, left, right? Alright. And same thing with linear. I'm going to see what it does, up, down, over, left, and right. Alright.